this is Captain Chaudhari in my series of videos on marine astronomical navigation. Today I want to talk about the subject as to what is the correct time or moment of taking the sun or moon's amplitude. Let me tell you the compass error finding by amplitude method, that is when we take the sun's amplitude in the morning or evening. It is one of the fastest methods to find out compass error. In fact, astronomical compass error can be found by two fast methods. One is by observation of Polaris and the second one is amplitude of sun or moon. What is the correct time to take sun's amplitude and what is the correct time to take moon's amplitude? Right. Before that, a little bit about the calculations we'll talk about. And amplitude is the arc of observer rational horizon or angle at observer's zenith. So let us look at the diagram of celestial sphere drawn in the plane of observer's rational horizon. This is observer's zenith, the highest point. And let us say there is this latitude 30 degrees and let us say there is this declination of say about 12 degrees and the sun is rising here. Now we see the sun in the rising position. If I draw the meridian passing through the sun, then this arc of meridian is called declination. So declination is measured on the meridian, right, with respect to the equinoctial. Whereas if you consider what is this arc of observer's rational horizon, from the center of the sun to the east point, this is called amplitude. Now amplitude is represented in east and depending on the declination, right? Now declination is south, so it will be represented as east something south. Now how to find out the amplitude? Amplitude is found by this formula, simple formula. Sine amplitude is equal to sine declination upon cos latitude. So let us say the declination of the sun is 12 degrees and latitude is 30 degrees north. So sine 12 degrees divided by cosine of latitude gives me 13.89 or say 13.9. So amplitude is, in this particular case, the amplitude is 13.9. So the suitable time for taking amplitude is when the sun is, they say, when the sun's lower limb appears about semi-diameter above the visible horizon. At that time, on the east side, when the sun's center is on observer's rational horizon, where does the sun appear to an observer? Suppose this is the sea and this is the line of visible horizon. The sun should appear something like this. So the sun's lower limb appears about semi-diameter above the visible horizon. This is visible horizon. So you must have heard from your seniors that the sun's amplitude should be taken at the time when the lower limb is approximately the semi-diameter above the visible horizon. It might be slightly more than the semi-diameter depending on your height of eye, the dip, right? So we will now do an approximate calculation, just an approximate calculation to find out the observed or the sextant altitude at the time when the true altitude is 0. True altitude is 0 means on the east side or the west side, the center of the sun is on the observer's rational horizon. Now to find out what should be the sextant altitude, we write down in the usual fashion sextant altitude is equal to, we don't know how much it is, index error. Let's say the index error is nil. So the same as the observed altitude. Dip, that depends on height of eye. So let's say a very small amount of dip, say 5 minutes. Okay. Refraction, when the sun is close to horizon, whether it is sun or moon, when the altitude is approximately 0, we say that the refraction can be taken as 34.5 minutes. Always negative, but when we are going upwards, it will be applied in a wrong way. Refraction normally negative, but when we are going upwards, let's take the refraction as positive. Dip is always negative, but when we are going up, let's take it as positive, right? So semi-diameter, let's take the semi-diameter of the sun, say 16 minutes, right? So if we are talking about the lower limb is positive, but when we are going upwards, it is negative. Parallax in altitude. Let's take a small value of parallax, say like 0.2 minutes. Parallax is always positive, but when we are going up, we'll take it as negative. That gives us the true altitude, which is 00 degrees 00 minutes. So when we are going upwards, these things which are positive, they will be applied as negative, and those which are negative will be applied as positive. So if we total up these corrections and taking these signs, because we are going upwards from true altitude section to altitude, the positive corrections are 34 plus 5, that is 39.5, that is 0 degrees 39.5, and negative corrections are 16.2. So approximately 23.3 minutes is the sextant altitude of the lower limb. This means that when you look at the horizon, approximately 23.3, this distance is approximately 0 degrees 23.3, which is slightly more than the semi-diameter of the sun, right? So you can see that the refraction plays a big role. Refraction has tendency to elevate the heavenly bodies. It elevates the horizon also, but the net effect is when the center of the sun is on the observer's rational horizon, the lower limb of the sun is semi-diameter or approximately semi-diameter above the visible horizon. Now let us do the similar exercise in case of moon. Now you must have rarely seen that somebody is taking amplitude of the moon. First of all, it is not a regular feature. Moon may not appear as full moon always. Plus, you may have the cloudy horizon, and moon does not have its own light. Like in case of sun, you definitely know that after sunrise there's a lot of light, and even if slightly cloudy, you are able to find the sun. But we need to take moon's amplitude when the upper limb of the moon is touching the visible horizon. And why is that? Why is that? So that is the reason that moon's amplitude is not very commonly known. But a mariner must know that moon's amplitude is not taken in the similar position as the sun's. We have studied that the lower limb should be approximately semi-diameter above the visible horizon. In case of moon, the story is different. This the mariner must know. And why it is different in case of moon? Every question that you ask about the moon, I would say this is because of close vicinity of the moon. This is because of a large horizontal parallax of moon compared to sun, where the horizontal parallax is negligible. So let's do the calculation to find out what is the suitable time or opportunity when the moon's amplitude should be taken. So we'll write down the altitude correction in the normal way: sextant altitude, index error, observed altitude, then dip, refraction, semi-diameter, and parallax in altitude. That will give you true altitude. So true altitude for sure is 0 degree 0 minute. We start with sextant altitude. Suppose the index error is nil, and then let us say dip is, let's take a small value, 5 minutes. In the normal course, it is always in the normal direction, it is always negative. Dip is always negative. Refraction is also negative, and when the body is at horizon, it is 34.5 minutes. Semi-diameter, let us take as 15.6 minutes. Now, the moon, I told you earlier that the upper limb is visible. So let's target the upper limb, not the lower limb. In the normal course, it is negative, but when we go upwards, we will reverse the signs. Now parallax in altitude is always positive, and the moon is at horizon. So let's take the parallax value close to 0. Let's take it as 58 minutes. Normally the parallax is always positive, but when we go upwards it is negative. So if we look at the corrections that are applied to 0 degrees 00 minutes, we add up this and this becomes 39.5 plus 0.6, that is 40.1, and plus 15 is 55.1 minutes, that is negative, and the positive is 58 minutes, which means 2.9 minutes, 00 degrees 00 degrees 2.9 minutes is the altitude, section to altitude of the upper limb. That means if this is the horizon, the moon is almost, the upper limb is almost touching the visible horizon. So this is the suitable time when the moon's amplitude should be taken. And the formula is same, sine of amplitude is equal to sine of declination upon cos of latitude.